So here we need to consider this geometric sequence. We have 8 times x minus 2, which is squared, 4 times x minus 2, which is cubed, 2 times x minus 2, which is raised to the 4th. And this goes on all the way to infinity. But then in order for this sequence to actually exist, that's if x is anything which is not 2. So now the first question is asking us to determine the value or the values of x for which the sequence converges, for which this geometric sequence is convergent. And we know that a sequence is convergent if the constant ratio is less than 1 but greater than -1. But the question is, what is the first thing that we need to do? Well, that's actually to calculate the constant ratio. All right? So, well, this sequence is 8 into x minus 2. And this is squared, 4 x minus 2 cubed, 2 x minus 2 raised to the 4th. And this goes on to infinity. Then we know that in order to find the constant ratio, we just need to say term number 2 divided by term number 1. They told us that the sequence is geometric, so we don't need to prove that it's geometric. So then 4 divided by 8, well, we simply get a half. And dividing powers of the same basis, we subtract the exponents. So this means we actually have x minus 2 divided by 2. Yes, this is what we are saying. This is our constant ratio. But then we need to tell them a little bit of an essay to say, for the sequence to be convergent, what must happen? Well, our constant ratio must be less than 1, but greater than -1. Please tell them this. It's terribly important. They need to know this. So in other words, x minus 2 divided by 2 must be less than 1, but greater than -1. And now it's time for you to solve for x. So you multiply throughout with the 2. And then you transpose the 2 to both sides. You take it to the left, you also take it to the right. So when it arrives on the right-hand side, it becomes positive, and 2 plus 2, that is 4. But when it arrives on the left, it's also positive, but then we get a 0. So these are the values of x for which this geometric sequence will converge. Then the question says, determine the sum to infinity of this series if it is given that x equals 2.5. Okay, so in order for us to find the sum to infinity, we actually need to know the constant ratio as well as the first term. So we already know the constant ratio, but in terms of x, so we need to find the actual constant ratio. They told us that x is actually 2.5. So our constant ratio will be 2.5 minus 2. And this is divided by 2. So when you go to your nice calculator and you say 2.5 minus 2 divided by 2, well, you simply get a quarter. So this must be the constant ratio. That's fine. You don't need to determine the series or the sequence itself. You just need to find the first term. And that means you only need to substitute x into the first term. So then your a, which is the first term, will be 8 into x minus 2, which is all squared. Of course it is squared. So when you now say 8 into 2.5 minus 2 squared, you find that a is going to be 2. Okay, fine. So now we know the first term. We also know the constant ratio. Then we can say the sum to infinity equals the first term divided by 1 minus the constant ratio. So we have 2 minus, in fact, divided by 1 minus a quarter. So when we plug in everything, we find that the sum to infinity will just be 8/3. Yes, that is the value of the sum to infinity. And you run away with your 4 marks. Well, here we are given a series which is represented in sigma notation. It's the sum of 3 times negative 2 raised to the k minus 2. It's the sum of this series, which is evaluated from k equals 3 to k equals 12. And the first question says, how many terms are there in this series? Well, that's a very good question. So just to ask one of you, how many terms do you think there are? Okay, is there anyone who volunteers to answer this one before I choose a person? You can just turn on your microphone and go ahead. Well, no one volunteers. Oh, sorry, sir.
10 terms.
10 terms. How did you find the 10?
Say it was 12 minus 3 plus 1.
Okay, thank you so much, sir. So the number of terms equals top minus bottom plus 1. So 12 minus 3, that's 9. Added to 1, we get a 10. This is the number of terms. Now that we know the number of terms, the question says calculate the sum of this series. Okay. Well, you can actually expand this series. That's perfectly fine. So let's do that actually. Even though we don't need to expand it, but let's expand it. Well, who says we don't need to expand it anyway? Now we need to expand it, so let's expand it. Well, I'm just going to clear this one out. So we have the sum from k equals 3 to k equals 12. And it's the sum of 3 times -2. And this is raised to the k minus 2. Okay. Well, when we expand this, in order to get the first term, we substitute k equals 3. So 3 minus 2, that's 1. You can show that you literally said 3 minus 2, or you can just show the final result. I think we should show that. Then you say, well, 3 into -2, 4 minus 2, 3 -2, 5 minus 2. But this goes on up until the last term, which we obtain by substituting k equals 12. All right. So what is this series going to be? Well, 3 times -2 raised to the 1, that's -6. And then if you say 4 minus 2, you get squared. So we get a 12. And here you get a cube. So it's -24. And this goes on up until the last term, which we substitute by saying k equals 12. Then we get 1372. So bottom line is the first term is going to be -6. And the constant ratio will be -2. That's fine. Then how many terms are there? We said it's 10 terms. So now we can go ahead and say, in order to find the sum of 10 terms, we know that we need to have the first term, which is -6, into, we take our constant ratio and we raise it to the number of terms. Then we say -1. And this entire thing is divided by the constant ratio minus 1. And if we now go to our calculator and we substitute everything there, we find that the sum of these terms will be 2046. So yes,